Good day, everyone. My name is Jazzie R. Hao. I'm currently a student of Master of Science in Applied Physics in Salle University, Manila. And on behalf of my co-authors, it is an honor for me to present our paper entitled Assessment of Municipal Solid Waste Management Scenarios in Metro Manila using the Long-Range Energy Alternatives Planning Integrated Benefit Calculator, LEAP-IBC system. For your reference, the outline of the presentation is enumerated in this slide. This presentation is divided into three parts. First talks about the introduction of the study, next is the methodology, and finally the results and discussion. And for that, we will be starting with part one, which is the introduction. Metro Manila is greatly populated compared to other parts of the country, as it has large number of establishments and modernized way of living. For the past 5 years, it generates biggest volume of wastes. In fact, in 2016, it produced 9,212 tons per day of waste, while in 2018, the generated waste increased by 24%, specifically increased to 11,401 tons per day. Unfortunately, only 85% of these wastes are collected, and the remaining 15% may be scattered in creeks, canals, and rivers. As one of the developing countries in the world, the country participates in formulating efforts to reduce greenhouse gas emissions in the atmosphere. Specifically on municipal solid waste management, there are laws that help to reinforce compliance of each member of the community and local government units. And for that, we have the RA 9003, or Philippine Ecological Solid Waste Management Act of 2000. This mandates the proper segregation, collection, transport, storage, treatment, and disposal of solid waste while eliminating waste incineration. So in short, the Philippines has existing laws to help manage solid waste in the country. Yes, there have been positive improvements and growth because some LGUs and private organizations initiated the implementation. And we can see this by the existence of waste diversion centers, junk shops, and materials recovery facilities. However, present national policy on solid waste management is still insufficient to deal with the management of the daily basis volume of the trash, since participants' poor compliance and reinforcement persist in being a challenge. So why does this kind of challenge exist in developing countries? This is because of the high rate of urbanization and population overcrowding. This has caused increase in waste generation. Now, the immense amount of solid waste is not the only issue to be concerned about, but also the different types of waste that are present from the mass, which convinces us the importance of waste characterization or being able to determine types of wastes and their amount, since this may be a source of potential benefits to the community and environment if properly segregated and appropriately collected. Now, so what are the general objectives of the study? First, examine the changes in environmental and economic impacts once a particular solid waste management scenario is applied. Then, we estimate the methane emissions from the landfills by incorporating the IPCC default methane estimation method in LEAP-IBC. Now, for the next part of the presentation, we have the methodology. The following assessment tools were used: the LEAP-IBC software in projecting total waste generated and methane emissions, and the Stata 15 in analyzing data from LEAP. Since each country has varying energy modeling approaches, the first step is for the LEAP-IBC. And we will use the modified LEAP default file for the Philippines, and then input the demographics and macroeconomics data under key assumptions. Methane emissions from sanitary landfills under municipal solid waste in the non-energy branch was calculated using the default method, which is indicated in the slide. For the third step, before we can use the IPCC default method, the total municipal solid waste generated is first calculated at the branch waste, as you can see here in the slide. Next is to get the DOC content, or the degradable organic carbon, which is manually calculated. The data for the waste characterization, population size, and waste generation rate were all derived from the 10-year solid waste management plans submitted by the NCR LGUs. For the fifth step, we have the business as usual scenario. And here we state that there is 0% methane emission captured, as this is the scenario where the usual practice of landfilling only takes place. For a more detailed analysis, we built a baseline scenario for each of the 17 cities in LEAP-IBC, which incorporated different figures for population size and waste generation rate. Next, we have the methane recovery scenario, which involves the implementation of the methane recovery in Metro Manila, assuming that 36%, 52%, and 54% of the methane emitted is captured for 2025, 2030, and 2040 respectively. To note, the baseline assumptions and targets are all based from the Philippines' short-lived climate pollutants reduction strategies of 2019. After exporting the results from each city in LEAP, we built a panel dataset which has cross-sectional data of the 17 cities that runs from 2010 to 2015. LEAP-IBC provides the projected data for methane emissions, population, and GDP per capita, while the life expectancy was taken from World Bank and was projected to 2050 using the extrapolate function in Excel. We now examine the relationship that exists between methane emissions and its predictors, the population, GDP per capita, and life expectancy using Stata 15. And we use the model indicated in the slide. According to Smith, there is a tendency for panel time series to be non-stationarity, and determining the order of integration as well as co-integration becomes necessary. Thus, a unit root test is performed to eliminate the issue of spurious regression. The next method that we have is the cost-benefit analysis. First is identifying and monetizing costs. What is a cost? Cost is considered to be reductions in the welfare of humans and society. In this study, this include collection, transportation, segregation, capital, operating, and management costs. Next is to identify and monetize benefits. What is a benefit? According to Atkinson, a particular observation is a benefit if it tends to increase human welfare. In this study, this includes revenue from recyclables, employment impact, electricity savings, health impact, and environmental impact. Next is to calculate the net present value and benefit cost ratio using 10% discount rate. After getting the NPV and benefit cost ratio, we perform sensitivity analysis in order to identify how the net present value will change if particular parameters deviate from their target and anticipated values. Analysis 1 considers varying the discount rate. Analysis 2 varies the efficiency of landfill gas technology electricity generation, while analysis 3 varies the rate of recycling collected waste from the total municipal solid waste generated. For the part 3 of this presentation, we have the results and discussion. First, we have the projection of total waste generated in Metro Manila. In 2010, we see that Metro Manila generated around 3.8 million metric tons of municipal solid waste. And by 2020, Metro Manila generates around 4.4 million metric tons of municipal solid waste. With municipal solid waste increasing over the years, it can be seen that Metro Manila's methane emissions coming from the municipal solid waste sector is also in an increasing trend. By 2050, Metro Manila could produce around 158.06 million metric tons of methane emissions from the waste sector alone. Quezon City, Manila City, and Caloocan City have large methane emissions due to their bigger population and waste generation rates compared to the rest of Metro Manila. Further, Quezon City has high methane emissions but low population density since it has the biggest land area. On the other hand, Manila City has a lower methane emission but has the highest population density. Next, Next is the projected methane emissions. We can see that methane emissions will decrease in methane recovery scenario compared to the baseline scenario when considering the effect of sanitary landfills. Greenhouse gas emissions show that the methane recovery scenario is better than the baseline. In the span of 40 years, a total of 10.2 million metric tons of carbon dioxide equivalent is avoided. Next, we can see the results for the ambient temperature. The rate of temperature increase in each scenario becomes more significant as the years go on. Thus, it implies that with slower temperature increase and a lower global warming potential seen under the proposed mitigation scenario, the adverse effects of climate change brought about by the short climate pollutant methane can be lessened, and future costs due to damages and drastic adaptation measures can be avoided. Since our net present value is greater than zero, this indicates that the project is economically viable and gives a better return on investment under specific assumptions mentioned before. The slight tweak in the present cost at the year 2030, as you can see in the figure, is due to the fact that the full potential of the methane recovery system is set to be achieved during this year, deploying 56% of the SLFs or sanitary landfills waste capacity for methane recovery. For the conclusion, the study calculated that Metro Manila generates about 3.8 and 4.5 million metric tons of municipal solid waste in 2010 and 2020 respectively, which continues to grow until 2050. As a result, the methane emissions from the waste sector will also follow the same behavior. Metro Manila is able to produce 158.06 million metric tons of methane emissions. The three most populous areas, which are Quezon City, Manila City, and Caloocan City, comprise the largest parts of this accumulated methane emissions. As a conclusion, the study produced a positive net benefit, indicating that methane is a viable option for electricity generation, of course, under specific assumptions. Castillo and Atoma detailed that only 4% of the LGUs in the Philippines uses sanitary landfills as their disposal facilities. Waste management cannot be done alone by the government, so LGUs are strongly encouraged to participate in future waste management plans. In 2016, only 15% of LGUs have access to sanitary landfills. So it is recommended to cluster sanitary landfills in the country in order for the LGUs to share costs in establishing each site. These recommendations are actually supported by the Section 13 of the Philippine Constitution that LGUs may group themselves and coordinate their resources, efforts, and their services for their benefit and the environment as long as it abides the law. This collaboration is also important because if some capacity of SLFs are not maximized, or at least the minimum amount of waste needed to generate substantial amount of methane for electricity generation is not achieved, then the costs associated with the whole investment of the landfill project might fail to generate the expected benefits above. And that is the end of the presentation. Thank you for listening.